Let's look at trigonometric integration with substitution. Okay. First one, integral of 8x cosec square 2x square plus 1 dx. Okay. Let's do the substitution of u is equal to 2x square plus 1. Its derivative would be du is equal to 4x dx. Okay. Now we want 4x dx we want. So let's take out 2. So this cosec square 2x square plus 1 becomes cosec square u, and 4x dx becomes du. And we know that cosec square u integral is minus cot u. Or if you look at it from the other side, cot u's, when we differentiate, we get minus cosec square u. So our answer is minus 2 cot u plus c. If we do the reverse substitution, we get 2 cot of 2x square plus 1 plus c. Okay. Second one, integral of minus 60 x square cos of 5x cube plus 3 dx. So here we take u is equal to 5x cube plus 3, du becomes 15x square dx. Now here, if you can think ahead, fine. Even if you can't think ahead, let's take minus, this is 15, 15 4 60. So let's take 4 out. We are left with 15x square cos of 5x cube plus 3 dx. So this becomes minus 4 cos u, okay, minus 4 cos u is sine u du. If we integrate cos u, we get sine u. So reverse substitution. So sine u is 5x cubed plus 3 plus c. Okay, let's look at the third one. Integral of minus 30x sec square 5x square plus 1 dx. Okay, so here the substitution would be u is equal to 5x square plus 1. Du would be 10x dx. So we want 10x inside. So let's take minus 3 out. We get 10x dx, that is du, and this becomes sec square u. And we know sec square u, if we integrate, we get tan u. And reverse substitution, tan 5x square plus 1 plus c. Okay. Fourth one, minus integral of minus 20x4 cosec square x to the power 5 plus 3 dx. Okay, u would be x to the power of 5 plus 3, du would be 5x4 dx. Now here we have 20. Here we have 20x4. We require only 5x4. So let's take out minus 4 out. We are left with 5x4 dx. So that would be du, and this becomes cosec square u. And if we integrate cosec square u, we know it is minus cot u. Okay. So this becomes 4 cot of x to the power of 5 plus 3 plus c. Look at the fifth one, integral of minus 16x cosec square 4x square minus 3 dx. U becomes 4x square minus 3. We do the substitution. Du would be 8x dx. So here inside we want 8x dx. So let's take minus 2 out. Integral of 8x dx, which is du, and we have cosec square. So cosec square u is minus cot u. So plus 2 cot of 4x square minus 3 plus c. Here you have a multiplication. Okay. Sixth one, integral of minus 30x sine of 5x square minus 2 dx. U would be 5x square minus 3. Du would be 10x dx. Now we want 10. So let's take minus 3 out. We have 10x dx. So that becomes du. And we have sine of u. And we know if we integrate sine u, we get minus cos u. So this becomes plus 3 cos of 5x square minus 2 plus c. That is sixth one. Let's look at seventh one. Let's change gears. Integral of minus 3 e to the power of x dx by cos square of e to the power of x minus 1. U would be here e to the power of x minus 1. Du would be e to the power of x dx. Minus 3 comes out. E to the power of x dx by cos square e to the power of x minus 1. So let's do the actual substitution. We get e to the power of x dx is du by cos square u. Now, don't get into too many complications. Let's convert it to, let's bring cos square u to the numerator. This becomes sec square u du. And we know that sec square is the derivative of tan. So tan u, which becomes minus 3 tan of e to the power of x minus 1 plus k. Eighth one, integral of 12 e to the power of 3x dx divided by cosec e to the power of x minus 3, not x, 3x. So now u is equal to e to the power of 3x minus 3. Du would be e to the power of 3x times the derivative of 3x, that is 3 dx. Now here we have 12, we require only 3. So let's take 4 out. We get 3e3x dx, which is nothing but du by cosec u. Again, let's bring it to the numerator. We get 1 by cosec is sine u du. And we know sine is the derivative of minus cos u. Okay. And again, let's do the reverse substitution. U is e to the power of 3x minus 3 plus c. Okay. Ninth one. Okay. Integral of minus 15 cosec of 3x cot of 3x times sine of cosec 3x dx divided by cos square cosec 3x. Okay. Now again, no need to panic. If we remember, we need to remember this. Cosec x derivative is cosec x cot x, right? So let's say u is equal to cosec 3x So du would be 3 times cosec x, cosec 3x here, cot 3x here, and there is a minus sign in the derivative. Okay. So now let's organize this. Here we have minus 3, we have minus 15. We require only minus 3. So let's take 5 out. We get minus 3 cosec 3x cot 3x and dx. Here dx is also there. Sine of u du divided by, we have cos square u, right? Okay. Now we can split this. We can say sine u by cos u times 1 by cos u. So sine u by cos u is tan u, and 1 by cos u is sec u du. And we know when we differentiate sec u, we get tan u sec u. So when we integrate tan u sec u, we get sec u. And reverse substitution, we get sec of cosec 3x plus c. Okay. 10th one. Integral of minus 20 sine of 5x dx divided by cos square 5, no, cos square cos of 5x, right? So now if we differentiate cos 5x, we get sine 5x, right? So let's take u is equal to cos of 5x. Du would be minus sine 5x times 5 dx, which becomes minus 5 sine 5x dx. We require only minus 5. So let's take 4 out. If we take 4 out, we get minus 5 sine 5x dx, minus 5 sine 5x dx. So this is going to be du divided by, this is cos square of cos 5x, so this will be cos square u. Again, if we take it to the numerator, we get sec square u du. And we know that this is the derivative of tan u. So tan u is going to be the integral of sec square u. And reverse substitution, we get 4 tan of cos 5x plus c. Okay, 11th one. Integral of 3e to the power of 3x dx by cos square of e to the power of 3x plus 1. Okay, u is equal to e to the power of 3x plus 1. Du would be 3e to the power of 3x dx. Basically, the idea is how do you figure out which one to substitute? So you look at this and see, if you differentiate this, do you get some part, at least some part of the numerator? Okay. Now, if we do the substitutions, we get integral of du by cos square u, which is integral of 1 by cos square u is sec square u du, which is tan u, which would become tan of e to the power of 3x plus 1 plus c. Okay, I'm in every problem I'm adding this constant of integration to the last step. Okay, 12th one. Integral of 6 cosec square 2x cos of cot 2x dx divided by sine square of cot 2x. Okay, now Let's take u is equal to cot 2x. If we differentiate it, we get minus, if in the end we are going to integrate 2x, so 2 will come, sorry, we are going to differentiate 2x, so we get 2. Let's write it in the beginning itself. Minus 2 cosec square 2x dx. Okay, so let's see what happens to our integral. This becomes 6 cosec square 2x dx. So here we require minus 2. So let's take minus 3 out and we get minus 2 here. So minus 2 cosec square 2x dx becomes du, and cos of cot 2x, this becomes cos of u divided by sine square u. So minus 3 integral of cos u by sine square u du, to write it properly. Okay, now again here we can split it. We can write it as cos u by sine u times 1 by sine u. Cos u by sine u is cot u. 1 by sine u is cosec u, right? And du. Okay, so now we can integrate this. This is the derivative of minus cosec u. So this becomes plus 3 cosec u is cot plus c. Okay, 13th one. Integral of minus 40x dx divided by cosec of 5x square minus 3. So u, let's make it as 5x square minus 3. Du would be 10x dx. We require only 10, so let's take minus 4 out. We are left with 10x dx, which is du, and in the denominator we have cosec u. Let's bring cosec u to the top. So this becomes sine u du. Now sine u, if we integrate, we get minus cos u, and this becomes 4 cos of 5x square minus 3 plus c. 14th one. Integral of 12 cos of minus 3x dx divided by sine square of sine minus 3x. Okay, let's take u is equal to sine of minus 3x. du would be, when we differentiate this, we get minus 3. So if we differentiate sine minus 3x, we get cos minus 3x dx. Right? Okay, let's do the substitutions. Here we have minus 3, we have 12. So let's take minus 3 cos of minus 3x dx by sine square sine of minus 3x. Okay, so here we will have minus 4, right? Because only when we multiply we get plus 12. Okay, so now minus 4 times this becomes du by sine square u, which is nothing but minus 4 times integral of 1 by sine square is cosec square u. So cosec square u du. Okay. Now when we integrate cosec square, we get cot u. But for it to be cot u, we require a minus sign here. So which means we make this plus. So we take minus inside. So minus cosec square u, when we integrate, we get cot u. So don't forget the negative sign. And reverse substitution, we get cot of sine of minus 3x. plus k 15th one, integral of minus 2 dx by x sec natural log of 3x minus 3. Okay, so we are changing gears again. Now let's do the substitution. Let's say u is equal to natural log of 3x minus 3. Differentiating it, we get 1 by 3x times, differentiating the 3x, we get 3 dx. So 3 and 3 cancels. So du is equal to 1 by x dx. And we do have, if we take minus 2 out, we do have 1 by x dx. So this becomes du by sec u. If we bring sec u to the top, we get cos u d. And if we integrate cos u, we get sin u. And substituting back, so sine of natural log of 3x minus 3. So this is the integral of that expression. So plus c, okay, 16th one. Okay, integral of minus 18x square cos of 3x cube plus 1 dx divided by sine of 3x cube plus 1. Okay, let's do the substitution. So let u be 3x cube plus 1. So du would be 9x square dx. Here we require only 9, so let's take minus 2 out. We get 9x square dx. So that will become du. And we have cos of u. In the denominator, we will have the sin u. So we have cos u and sin u. Now the trick is to do substitutions again once more. So let s is equal to sin u. So ds would be cos u du. So when we do the substitutions again, we get cos u du is ds by sin u is s. And we know that this is the derivative of natural log of absolute value of s. So now let's start reversing the substitutions. So natural log of sin u, and now u is 3x cube plus 1. So minus 2 natural log of sine of 3x cube plus 1 plus c. So this is the integral. Okay, 17th one. Integral of minus 2 e to the power of x sine of e to the power of x plus 2 dx divided by cos of e to the power of x plus 2. So let u is equal to e to the power of x plus 2. Du would be e to the power of x times 1. So e to the power of x dx. Now we can take minus 2 out. So we have e to the power of x dx, which is nothing but du. We will have sin u by cos u. And in the previous problem, we really did this sin u cos u, right? No, we had cos u by sin u. So let's do this. So here what will happen? Again we do the substitution. Let s equal to cos u. So ds will be minus sin u du. So let's do the substitutions. Sin u du is, now if we take this here, we get minus ds by cos, no, by s. So again we can take this minus out, so this becomes plus. We have ds by s. and we know this will be natural log of absolute value of s, and s is cos u, so natural log of cos u, and we know u is e to the power of x plus 2, so e to the power of x plus 2 plus c. Okay, great. Now 18th one. Okay, integral of 2 dx by x cosec of minus 4 plus natural log of minus x. Okay, let's take u is equal to minus 4 plus natural log of minus x. So du would be, this will be 0, and this will be 1 by minus x times minus 1, right? So which means this will become 1 by x, and of course dx is also there. So what do we get now? We get 2, we can take it out, so we have dx by x, so which is nothing but du by cosec of u, which is equal to sin u, and if we integrate sin u we get minus cos u, and reverse substitution will give us minus 2 cos of minus 4 plus natural log of minus x plus c. So that is the result. So that is trigonometric integration with substitution. That's it. Bye.